Where did our moon come from? Scientists' new theory surprised everyone. In a new theory, scientists claim that our moon was not formed by the collision of a planet. Rather, it came from outside and the Earth had pulled it to itself, so that it has been with us forever. For this, scientists have given their new binary system capture theory, which answers many questions that the old theory was unable to give. Where and how did the moon come into our solar system and near the Earth? There has been a popular theory of this for decades. Millions of years ago, a planet collided with the Earth and they named Theia, and the scattered pieces of the collision slowly turned into a body we call our moon today. The truth behind this theory is not yet fully established, but it is giving scientists an opportunity to better understand the story of our Earth and the moon. According to scientists, an ancient planet named Theia collided with Earth about 4.5 billion years ago. This phenomenon occurred in the early days of our solar system, when the process of planetary formation was going on. It is considered part of the giant impact hypothesis, which is the most widely accepted theory of explaining the formation of the moon. What was Theia? Theia was a Mars-sized planet or protoplanet that formed elsewhere in the solar system. The name Theia is derived from Greek mythology. Theia was a goddess who is considered to be the mother of the moon. The name reflects the idea that the moon was formed from Theia itself after the collision. It came to him during the process of formation of the Earth and eventually collided with him. The collision was extremely fast and fierce. Their debris was scattered in space by the energy and heat of both planets. The size of the Earth became slightly larger after the collision, as part of Theia was absorbed into the Earth. The debris from the collision, Theia and pieces of Earth, spread out into space and began to move around the Earth. Over time, this debris coalesced and solidified and formed the moon. The composition of the moon has a fraction of both Earth and Theia. Theia and moon evidence. The oxygen isotopes found in moon rocks and isotopes of Earth rocks are almost identical. It shows that some part of the moon has emerged from the Earth. Theia's core merged with the Earth's core, making the Earth's iron core even larger. The moon has a relatively low core, which confirms this collision. The gravitational relationship between the Earth and the moon and the inclination of the moon corresponds to this collision. The collision tilted the Earth's axis, causing us to experience seasonal changes. The collision warmed the Earth again, making its core and mantle more flaky and solid. Due to this incident, the environmental balance of the Earth got a unique form, which helped in the development of life. This collision of Theia and Earth not only tells the story of the formation of the moon, but also shows how the early chaos of our solar system played a role in creating a suitable planet for life. This event was the beginning of the deep connection between the Earth and the moon, which has remained to this day. Scientists are now trying to understand more precisely the structure of Theia and how this collision occurred. Advanced missions like Chandrayaan-3 and NASA's Artemis program will gather more data from the lunar surface. With this research, we will also be able to understand how the other planets of the solar system formed and how important this event was for life on Earth. From time to time, there has been a lot of scientific evidence in favor of this theory, but the new study has caused a stir in the world of science because it is making a different claim to the old theory, which has proposed that it is not from a collision but through a special binary exchange process. How was the first possibility adopted? Scientists at the Kona Conference in Hawaii in 1984 agreed on the origin of the moon, based on analysis of lunar soil samples for NASA's Apollo missions, and found that the moon's soil composition closely resembled that the early Earth the moon would have formed after a collision with a celestial body. Why did the old theory become popular? The theory, popularly known as impact theory, gained widespread support because it appeared to be in sync with the known composition of the moon, but it did not include all the elements. Researchers say that if the moon were made up of the pulleys of a body, it should have revolved around the Earth closer to it. Tilt of the moon's orbit. The moon's orbit is tilted 7 degrees below the plane of the Earth's equator. This also contradicts the impact theory. To explain this anomaly, the researchers turned to the concept of binary exchange capture, in which they proposed that the Earth could have dragged a rocky object passing by and brought it into its orbit and made it its satellite. This also happened with Neptune. Triton is now believed to have come from Neptune's Kuiper belt and became its satellite. The Kuiper belt across Neptune has a large number of rocky objects, 1 in 10 of which is part of the binary system. Like our Moon, Triton orbits 67 degrees above Neptune's equator hooked. More hints. In the study, published in the journal Planetary Science, the researchers calculated that the Earth could pull an object with a mass of 1 to 10% of its total mass into its orbit, and a Moon with a mass of 1.2% within a distance of 128,750 kilometers. And it should pass near the Earth at a speed of 10,800 km per hour. The biggest advantage of this theory is that it explains the tilt of the Moon's orbit and also explains the presence of elements that are on the Moon but not on the Earth. Researchers say that such binary systems used to be more in the early solar system. Researchers from Penn State University have proposed a new theory in which they show that the Moon was originally part of a double pair of rocky bodies orbiting each other in space, and that when the system passed close to Earth, the gravitational force of our planet would have pulled one of these objects into its orbit while the other body was in space. Must have gone somewhere far away. Not one but two theories. This theory has been proposed by Professor Darren Williams and his team. No one knows how the Moon would have formed. For the last 4 decades we had one possibility. Now we have many. The new theory also answers questions that the old theory was unable to offer. Coformation theory. This idea is also one of the theories explaining the origin of the Moon. This is often called the binary accretion theory. According to this theory, both the Earth and the Moon were formed, at the same time, of the same basic material, but as two different celestial bodies. Let's understand this in detail. About 4.5 billion years ago, when the solar system was forming, a portion of the huge cloud of gas and dust gave rise to the Earth and the Moon. These clouds allowed the Earth and the Moon to form separately but close by. Both the Earth and the Moon tied each other with their gravity, causing the Moon to revolve around the Earth. The Moon and Earth began to form and evolve at the same time. Their chemical and physical properties remained the same. Arguments in favor of the theory. The similarity in the material of the Moon's rocks and the Earth's, especially oxygen isotopes, indicates that both may have originated from the same source. There was a possibility that bodies formed in the same region in the early days of the solar system could revolve around each other. Several binary systems, gravitational bonds of two bodies, have been observed in our solar system. For example, Pluto and its moon Charon. Binary systems between some other asteroids and their satellites. The Pluto-Charon system is a good example of this, where Charon treats Pluto almost equally. Arguments against the principle. There are some differences in the composition of the Earth and the Moon. Example, the Moon has a very low iron content, while the Earth's core is rich in iron. This indicates that both may have been formed under different conditions. If the Moon had formed alongside the Earth itself, it should have been in a relatively circular orbit. But the current orbit of the Moon does not support this. Debris and boulders on the surface of the Moon suggest that it could be a reaggregation of Earth's material, which supports the giant collision theory. But in the Earth-Moon system, the Moon is relatively small and this type of double-body system theory does not fit perfectly with the Earth. If this theory were correct, it would help us understand how many planets and their moons formed in our solar system. Although coformation theory is fascinating and offers a simple way to explain the deep Earth-Moon connection, most scientists do not consider it alone enough. The formation of the Moon is probably the combined result of the giant collision theory and other processes. But it is clear that the relationship between the Earth and the Moon is very old and complex, which helped shape life on Earth. Processes such as giant collisions, coformations, and subsequent captures can all play a role in its creation. Scientists are now trying to understand whether the internal structure of the Moon and the materials on the surface prioritize any one of its formation processes. Capture theory. This theory is one of the possibilities studied by scientists for a long time. According to this theory, the Moon was an independent celestial body separate from the formation of the Earth, formed elsewhere in the solar system and later pulled by the Earth's gravitational force. According to this view, the Moon was formed in some other place from clouds of gas and dust in the early stages of the solar system. It was a rogue celestial body that passed close to the Earth. When the Moon came close to the Earth's enormous gravitational force pulled it permanently into its orbit. Instead of colliding, the motion of the Moon slowed down and it began to revolve around the Earth. Over time, the Moon's orbit stabilized, and it began to show the same face to the Earth, always due to tidal locking. Arguments in favor of capture theory. Some variations in the chemical composition between the Moon and the Earth have been found. This indicates that they cannot be made in the same place. There are many such examples in the solar system, such as Mars satellites Phobos and Deimos, which are likely captured celestial bodies. The Moon's orbit is not perfectly circular, which lends rise to the possibility that it did not naturally form with the Earth. Arguments against this theory. If the Moon had been attracted to the Earth, it could have collided directly with the Earth, or it could have been thrown out again before its orbit stabilized. The rocks of the Moon and Earth have a combination of oxygen isotopes, which suggests that they are formed from the same original source. This makes the giant collision theory more robust. Computer simulations show that the process of catching the Moon would have been so complex that it is highly unlikely. However, this theory has come up again in the scientific community. In recent years, new studies on the Moon have revealed some mysterious things, such as the uneven distribution of heavy metals and structures in parts of the Moon and lunar material, such as some meteorites coming from outside the solar system. These discoveries have led some scientists to wonder if the Moon really formed and was later captured elsewhere outside Earth. What is the effect of the Moon on our Earth? The Moon is not just a celestial body that gives light at night. It has a profound impact on the Earth. The gravitational force of the Moon generates tidal tides in the seas. This not only affects marine life but is also slowing down the rotation speed of the Earth. The Moon helps to keep the Earth's axis stable. Without it, the Earth's axis could have been so unstable that the weather and climate would have changed drastically. What is the surface of the Moon and its structure? There are craters on the Moon, which are formed by the collision of meteorites. Its color is between gray and white because there is dust and stones on its surface, called regoliths. The Moon has no atmosphere, so there is no possibility for air, water or life. The Moon always shows the same face to the Earth. This is caused by tidal locking. The part of the Moon that we never see is often called the dark side of the Moon. However, this part also receives sunlight, but is not visible from our Earth. The Moon has a deep connection with our festivals and traditions. Rituals like Karwa Chauth and lunar eclipse. The Eid moon heralds the end of an entire month of fasting. Many poets and artists of India have considered the Moon as an inspiration. The Moon has often been considered a symbol of love and beauty. Man's step on the Moon. During the Apollo 11 mission in 1969, Neil Armstrong and Buzz Aldrin became the first humans to walk on the Moon. He famously said, "This is one small step for a human being, but one giant leap for humanity." India has also played an important role in the study of the Moon. Chandrayaan-1, 2008, India's first lunar mission, which discovered water molecules on the Moon. Chandrayaan-2, 2019, this mission tried to study the south pole of the Moon. Chandrayaan-3, 2023, this successful mission of India could make a soft landing on the lunar surface and became the first mission to land on the South Pole. Life on the Moon in the future. Work is being done on the plan to build a colony on the Moon. NASA and other space agencies are preparing for missions that could develop the Moon as a future destination. Scientists are trying to understand if it is possible to live there using the water of the Moon. Why is the Moon so close to our hearts? The mysterious beauty of the Moon, its influence on our lives, and the endless questions hidden in it attract us to it. The Moon gives us a sense of light in the darkness of the night and inspires science to cross its limits. Recent Moon missions, such as Chandrayaan-3 and other NASA missions, have indicated that the history of moon formation is very complex. What will happen in the future? Advanced space missions like the Artemis program and India's Chandrayaan-3 are studying the lunar surface and composition in depth. These can help us understand what the original source of the moon is and whether it is actually Earth's natural companion or guest who became permanent. Interesting facts. The moon is moving 3.8 centimeters away from the Earth every year. Its gravity is 6 times lower than that of Earth. If you are standing on the moon, the sky will always look black because there is no atmosphere. This journey to understand the origin of the moon not only explains our solar system better, but also explains how important the role of the moon is in the development of life on Earth. What might happen in the future? NASA's Artemis program and other moon missions could bring new information related to the lunar surface and its formation. The tilt of the moon's orbit and its internal structure can be better understood. Advances in computer simulations and gravitational modeling will explain how the tilt of the moon's orbit evolved. The story of Neptune and Triton also illustrates just how complex the origins of planets and their satellites can be. Let's figure it out. Triton, Neptune's largest moon, is the only large satellite in our solar system that revolves around Neptune in retrograde orbit. This irregular orbit demonstrates that Triton is likely not Neptune's parent moon. Scientists believe that Triton is a captured object. It probably came from the Kuiper belt, which got caught up in Neptune's gravity. During this capture, Triton caused gravitational disruption with Neptune's parent moons, causing a change in their orbital configuration and throwing several smaller moons into space. Triton was originally an independent body or possibly part of a binary system. When it passed near Neptune, Neptune's powerful gravity pulled it through. If Triton was previously part of a binary system, Neptune's impact broke that binary, causing Triton to begin orbiting Neptune. Initially, Triton was in a highly irregular orbit around Neptune. Over time, due to Neptune's atmosphere and gravitational influence, Triton's orbit became more stable. The gravitational upheaval generated during Triton's capture destabilized Neptune's parent moons. Many of the original moons were thrown out of Neptune's system or fell into Neptune. Triton's orbit in the opposite direction is the strongest evidence of this. If Triton had formed with Neptune, its orbit would have been prograde, i.e. with the direction of rotation of Neptune. Triton's size, composition, and surface properties, such as the presence of frozen nitrogen and methane, make it more similar to other Kuiper belt objects in the solar system, such as Pluto. This shows that Triton was not originally related to Neptune. The gravitational influence of large moons such as Triton would have destabilized the orbits of other potential moons of Neptune, causing them to disappear. Similarities between Neptune Triton and Earth Moon. Neptune captured Triton by gravity, while in the Earth-Moon system it has been suggested that the moon formed from Earth's debris. But capture theory is sometimes seen as a helpful model even in the case of the Earth-Moon. Triton's orbit is much tilted from Neptune's equatorial plane, as is the moon's inclination to Earth's equatorial plane. In both cases, it can be the result of gravitational perturbations and initial orbital instability. Triton is slowly pulling towards Neptune. Scientists estimate that in the coming about 3.6 billion years, Triton could collide with Neptune or break away to form rings around Neptune, like Saturn's. Evidence of cryovolcanism has been found on the surface of Triton, which makes it an attractive target of study for scientists. Future missions, such as NASA's possible Trident mission, could uncover the mysteries of Triton and the Neptune system. The story of Neptune and Triton shows that the history of planets and their moons is not simple. Triton's capture and its retrograde orbit make it one of the most mysterious moons in the solar system. Triton's pull in Neptune's gravitational field and its possible impact help in understanding the complex dynamical processes of the solar system. This phenomenon also inspires scientific comparisons in terms of the tilt of the Earth and the Moon and the probabilities of their origin. If you like this video, then like, share and subscribe.